Alright, so this lesson we're going to be talking about scatter plots and lines of best fit. So a scatter plot is a graph that shows the relationship between two data sets. The two data sets are graphed as ordered pairs in a coordinate plane, and the scatter plots can show the trends in the data. And I'll give you an example of what that looks like. So correlation is a relationship between data sets. You can use a scatter plot to describe the correlation between the two data. So the positive correlation, so if you notice the first graph here, the first graph has all your dots. The dots, if you look at the dots, they're going up, an upward trend. Right? So as the x value increases, the y value increases as well. So each one of these dots represents two data sets. All right, so each one of these dots, or scatter plot, represents two data sets. And what do I mean by two data sets? All right, so let's say this dot here. Right, this could be, my x value could be something in hours. So after 1 hour of playing Battlefront, I got up to level 5. And after, let's say, 3 hours of playing Battlefront, I got up to level 6. Right? So each one of those there's two sets to it, two values to it, right? So one is the x value has time, the y value is a level. And if they're all on an upward trend, like the first one here, then it shows a positive correlation between the two data sets. The second one here is a negative correlation. So as the x value increases, the y value decreases. Okay, so as the x value increases, the y value decreases. This could be any kind of example. So years ago, we used to use the libraries very often for everything. Now you guys have the internet. So as years increase, the time spent in a library tends to decrease. When you guys get your cars and start driving, as your age increases, your insurance starts to decrease. So as a first-year driver, you're going to be paying a lot of money to insure your car. As your years increase, maybe after 10 years of driving and no accidents, maybe you'll pay less. Hopefully after 30 years and no accidents, you'll pay less again. So as the years increase, the insurance payment decreases. And the last one is no correlation. All right, so one has nothing to do with the other. All right, so potentially maybe like age, like person's age, and how many siblings they have. Does it matter? I could be in my 30s and have 2 siblings. Miss Torres could be in her 20s and have 8 siblings. Okay, so there's no correlation between age and siblings. Okay, so here's your 3 correlations there. And another one that we've not mentioned here is it could have a correlation, but it doesn't have to be linear. Okay. So this one, if you look at, is linear. Looks like a straight line. This is linear. This is none. But you could also have correlations that are nonlinear. Right? So the scatter plots can look like something like this. Just one example. All right? And this is actually a quadratic. Right? So it can fit a quadratic model. All right, and we'll talk about these later on. For now, we're going to stick to the positive correlation, negative correlation, and no correlation. So here's 2 examples. So age and vehicles owned. So the person's age and the number of vehicles owned. Does that show a positive correlation, negative correlation, or no correlation? For this first one here, for I. Positive, negative, or no, or none?
There's no correlation.
Yeah. Yeah, there's no pattern with the coordinates there. There's no correlation there, right? It doesn't matter how old you are. You could be 35 years old and have owned 2 cars. Or you could be 35 years old and own 6 cars. Or you could be 35 years old and owns 12 cars. Okay, so there's no correlation in age and vehicles owned. What about the temperature and the coat sales at a store? Temperatures and coat sales at a store. Yeah, it's a negative correlation. Can you tell me why? Should make sense of it? Okay, as x increases, y decreases, but keep it in like general words. What does it mean? As temperature increases, the coat sales go down. Here's your temperature of 35 to 40 degrees. That's more or less winter-ish. 20 degrees, 35 degrees, a little bit less. What happens in the winter? What do we all tend to do in the winter? Yeah, we tend to wear coats, so during the winter, coats sold is going to be a higher number than when the temperature's at 70, 80, 90 degrees. What do we not do so much in the 70, 80? Yeah, we tend to wear less coats, right? Maybe a slight jacket just to look cool or something. If it's a really nice jacket, I don't know. Depends on the outfit, right? Okay. Next one. All right, so this next one, so we're going to make a scatter plot of the data and tell whether the data shows a positive, negative, or no correlation. And we could usually do this on graph paper, but we're actually going to do this on the TI-84 calculators. So we're going to graph these on the TI-84. First step, from a blank screen, we're going to hit the stat button. It's going to bring me here. Once we hit the stat, number 1 is already highlighted under edit, hit enter. We're going to edit that one. Okay. Once we hit edit, okay, so your list 1 and list 2 should be cleared. If they are not cleared, okay, if you want to clear those lists, you're going to go, let's say I have numbers here. I'm going to take my highlighter, I'm going to go to list 1, I'm going to go up to list 1 where L1 is highlighted. I'm going to hit clear and enter. And if you want to clear list 2, same thing. You take your cursor, move it over to L2, go up on L2, highlight the L2, hit clear and enter, and your list 1 and list 2 should be cleared. Now list 1 is going to act as our X value. List 2 is going to act as our Y values. So we're going to enter these numbers here. So we have temperature as X and attendees as Y. And let's start with the temperature. So we have 82. So I'm going to hit 82. Enter. 78. Enter. 68. Enter. 87. Enter. There's a few more. 75. Enter. 71. 92. And one last one, 84. And if you notice where it says L1, it says in parentheses 9. So right now you have 8 numbers in L1 on your first list. Okay. When we do scatter plots, we have to make sure we have the same amount of numbers in the second list. All right. So otherwise, we'll have an error and we won't be able to continue. So our list 2, we're going to put the attendees. So we're going to go with our first one, 4.5. Enter. 4.0 or just 4. Enter. 1.7. 5.5. 3.8. 2.9. 4.7. One more, 5.3. So now I have my list 1, my list 2. I have 8 numerical values in list 1, 8 numerical values in list 2. We are ready to make our scatter plot. Okay. Once we are here and we want to create the scatter plot, okay, we're going to hit second and y equals, which right above it says stat plot. So that's what I want. Second stat plot. And it brings me here. It says stat plots. And they should all be off right now. So I'm going to hit enter on the first one. And I'm going to turn my first plot on. So right now it's off and the cursor is blinking on the on button. Let's hit enter on the on button. Alright, so now it's on. The second item listed is type, and the first one that's listed is actually the scatter plot that I want. Right, those are all the dots. We want that kind of scatter plot. If you look at the other ones, it has a line, you can create a line, it has a bar graph, it has box and whiskers, right? So it has a couple different features. And then we're going to go to list, X list. This should say list 1. Okay, so if it doesn't, we're going to hit second and 1. And that will hit say list 1. So if you look at the number 1, right above it says L1. For my Y list, I want this to say list 2. So I'm going to hit second, 2. That's going to be my X list is L1. My Y list is L2. Okay. And the mark is when we make our scatter plot. These are the different symbols they can use. They can use a square, plus sign, dot, or a smaller dot. And then if you have a color calculator, you can choose your colors, but no big deal on that one. Once we are here, we're going to hit zoom. And if you look at the choices, number 9 says zoom stat. And we're going to hit number 9 and hit enter. So from the stat plot, I'll go back one more time. Once I'm here, I'm at this information here. I'm going to hit the zoom key. Brings me to these choices. I'm going to hit number 9, zoom stat, and it makes my graph for me. From our calculator, this is the scatter plot that we have. I'm just going to take this and blow this up on the screen here. So this is the scatter plot we got from our first one. Now from here, now decide, is this a positive correlation, a negative correlation, or no correlation? Yeah, this is a positive correlation, okay? So if you were to draw an imaginary line here, which we will actually be doing very soon, okay, this line kind of fits the data set, and this line is going in an upward direction, and we know that this line has a positive slope. So a positive slope can be similar to a positive correlation. So if we're looking at this here, and we try to make a sentence of this, what would the sentence be as far as temperature and attendees? What can you say as far as the temperature and the attendees on this one? Yep. So as the temperature increases, the number of attendants increases as well. So here's my temperature here on the bottom. So as the temperature increases, right, this could be 0, let's say 100 degrees Fahrenheit. The number of attendees will also increase too. This could be 1,000, 2,000, and so on. Alright, so we're going to do the same thing for the age of cars and value in thousands. And after doing so, you should get a scatter plot that looks something like this. And again, you could draw a line in between. Try to get your line in between as many points as possible. And what can you say about the correlation here? What can you say about the correlation here? So you have a negative correlation. And if we were to put this in words, okay, so we have age of car and value in thousands. How would you put this in words? So you have a negative correlation, and how would you use words on this one? Yeah, perfect. So as the age of the car increases, the value of the car decreases. All right, so that's what you would use as your words. All right, so negative correlation implies increase in car age, decrease in value. All right, let's take a look at our next example. When using lines of fit to model data, so we kind of just drew a line in there on the last one. All right, when you draw this line in there, I'm not trying to connect as many dots as possible. I'm trying to get in between as many dots as possible. Okay, so I'm not trying to connect as many dots as possible. I'm trying to get in between as many dots as possible. Okay. So when data shows a positive or negative correlation, you can model a trend in the data using a line of fit or a line of best fit also. And a line of best fit or a line of fit is a line drawn on a scatter plot that is close to most of the data points. That is close to most of the data points. Right? And the line of best fit is also known as a regression line as well. So our next example here, the table shows the weekly sales of a DVD and number of weeks since its release. Write an equation that models the DVD sales as a function of the number of weeks since its release. Interpret the slope, and y-intercept of the line of best fit. So let's take a second now and let's put these information into my calculator. So I'm going to bring up my calculator again. And I'm going to put this information down in my list 1 and list 2. And clear my list 1. So again, go to L1, hit clear, enter. And go to L2, hit clear, hit enter, and that clears both my list 1 and list 2. Alright, so my weekly is 1, 2, 3, 4, 5, 6, 7, 8. So I'll just go back up there. So I got 1, enter, 2, 3, 4. Alright, so I got my 1, 2, 3, 4, 5, 6, 7, 8, and my list 1. And then these sales, I'm going to go over. My first one is 19. Second one is 15. 13. 11. The fourth one. 10. 8. 7. 5. Okay. So make sure your data on L1, the number of data you have in L1 matches up with the number of data you have in L2. And I'm going to make a scatter plot of this again. And hit second y equals, go back to there. Where it says stat plots, and hit enter. I'm going to make sure that my plot is on. I'll make sure the type is on scattered. I'll make sure the list is on the correct list, list 1, list 2. And I'm ready to graph this. So I'm going to zoom. I'm going to go down to zoom stat, or number 9. And we have my data here. So I'm going to steal this screen here. Okay, and I want to show you one more thing. If you're on the data and you hit the button trace, it actually will tell you what the value is at that mark. So when x is 1, y is 19. So that scatter plot was 119. The next one is 215. And you could jump through all the scatter plots and see what this are. So the first one is 119. And I have another one down here, which is 85. So just to show you this one here was 119. And this last one here was 85. And you can get all the ones in between as well. And your line of fit is, again, going to try to go in between as many points as possible. So it looks like it'll be around there, trying to get as many points above and below as possible. So let's go back, and so we have this point here, 119, and let's see if we could find what that coordinate was there, just to give myself 2 coordinates. So that coordinate there looks like it was third coordinate up, so that looks like it was 6, 8. This one is 6, 8. So to find my slope, find 2 coordinates that are close to or on the line of fit, or line of best fit, and let's find our slope there. So we have m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. My first coordinate here is 119, so I'm going to say my y values are 19 minus y value here is 8 over 1 minus 6. 19 minus 8 is 11. 1 minus 6 is -5. So my slope is negative 5/11. 11/5, sorry. Was finding the slope, which we found was negative 11/5, and the last one was the y-intercept. Well, if you look at your graph, here's your line. This is at 19 and going up a little higher. What can you estimate the y-intercept to be, roughly? And again, it's just an estimate. What do you think the y-intercept is going to be? Yeah, 0, so you can say about 20 or 21 as the y-intercept. And I would take either one out of the place. Alright, so it has to be higher than 19, because 119 is here. So 0 will be here, and about somewhere in that range there. So where is that range? About 20 or 21. Alright, so let's take another look at another example. where it's just getting information from the scatter plot. So the scatter plot shows the hard drive capacities in gigabytes and the price in dollars of 10 laptops. So it says, the first one says, what is the price of a laptop with a hard drive of 8 gigabytes? Okay, so 8 gigabytes, my gigabytes here on the bottom. Here's my 8. If you run up on the 8, we are here. And if we look on the Y value there, we could say that the price of a hard drive with about 8 gigabytes is approximately what? Yeah, about $1,100. Okay. What is the hard drive capacity of a $1,200 laptop? So $1,200 is here. Yeah, and 12 is here. So about 12 gigs. And what tends to happen to the price as the hard drive capacity increases? Yeah, so as the hard drive capacity increases, so as my X values are going up or increasing, 0, 2, 4, 6, 8, 10, 12, so on, the dollar amounts of all these laptops also increases. So as the hard drive capacity increases, the dollar price increases as well.